the recording, and if I don't want the transcript. So anyway, so as I said, first things first, as I said before, I selected these items as, you know, these are kind of traditional topics that students kind of find hard. So a question or from a recent mock or anything like that, so please make sure that you know, you can put it on the chat. Topic that you have a pen and paper. So we're going to start with the first list, which is algebraic proofs. Find these ones very tricky. So the main thing that we've got in this question is that we got the word prove. Okay, so we have to prove, and it's asking me the sum of consecutive integers, and then that is divisible by 3. So anything that is divisible is something that is going to look like this, like 3m, and of course m, an integer. So basically, div 3 means that is on the 3 times table. So what we need how to proceed with this is we need to actually write 3 consecutive integers. So if n is one integer, the next will be n at 1, and the next one will be n at 2, which is n at 1 at 1. So the sum of the three we can call this S, will be the first plus the second plus the third. So I'm going to give you some time now to see if you can simplify this. You can see this. See if you can simplify this expression. So we have n at n plus 1. So the 3 n's, we've got n plus n plus n. Those together will give me 3 n's. We've got 1 at 2, which is 3. But of course, I can write this as 3 times n at 1. And the most important part of this part of the proof is that, of course, because n is an integer, remember n is an integer, that means it's a whole number. That means that n plus 1 is also an integer. So that means that we can write that as 3m. Hence S is a multiple of 3 or is divisible by 3. You can just say both things, multiple of 3 or is divisible by 3. Okay, divisible by 3. Okay, so that is one little bit of a warm up. If you have any questions, please put it on the chat, and that's the way proof. Let's just do another one. So I give you time to just write it down. So n plus 6x squared minus n plus 2 squared is always a multiple of 8. So to have a multiple of 8, what we need is 8m. Okay, we need to have 8m. So whatever we have to show that it's always is going to be able to. So at some point, we're going to take 8 common factor. So first of all, we need to do some algebra. So we need to expand this bracket. Okay, and then we'll expand this bracket underneath. So see if you can how to do this. So I give you just 1 minute to see if you can do that. So see if you can expand that. So that's the skill that we need. Okay, so we should be able to expand that. So there are different ways. So for example, one way you can do that is with the grid. Some of you are familiar using grids to do that. So you've got n, 6, and n at 6. So you've got n squared, 6n, 6n, and 36. Or you can actually use FOIL if you want to write them like this, n plus 6 times n plus 6. But I think all of you are comfortable doing this and expanding this. So we've got n squared plus 6n twice, 12n plus 36. And similarly with n plus 2 squared, if you want to write them like this, you got n squared, then you've got 2n at 2n, 4n at 4. So now that we've done that prep, well, we can write n plus 6 squared minus n squared. So we write the first one, n squared plus 12n plus 30. And then we take away, careful here, because we need to take away everything. So I always put the bracket first so I don't make a mistake. And then I've got that, so it's n squared plus 4n plus 4. So remember that the minus has to affect everything inside of the bracket. So we've got n squared 12n plus 36 minus n squared minus 4n 4. So as you can see, this simplifies with that one. And then what we have is minus 4n is 8n. 36 minus 4 is 32. And we are nearly there, because of course, remember, we have to show that it's a multiple of 8. So we can take 8 common factor. So 34 divided by 8 is 4. And so n plus 4 is an integer. So we've got am. So hence is a multiple of 8. So is okay. So can have a show of thumbs up. But okay with this. If anyone has got any question, please feel free to ask or comment. So if you if it's got any questions, or please feel free to say, and if not, then I will move to the. So, and then the next example is prove that it's always a multiple of 5. And this one is very simple in the sense that when you expand that, so this is one that you can write down now. So please just write n plus 10 minus n plus 5 squared. But as you can see, when you expand it, you will end up with an n squared and another n squared. So it will start with n squared. This other one will start with an n squared. So they will cancel, and then you'll be able to take a common factor of 5 at the end. So once you've seen a couple of these questions, you can see what the method to follow. Okay, so you can write this one down and you can try that yourself later on, because I'm mindful of the time. we cover a few things. Okay, so now the next thing is the trigonometric graphs. So you should have a calculator at hand. And one way I can remember what is the graph of the sine is the graph of the sine begins with an S. So an S, something like that. So that helps to remember. But if you've got your calculator at hand, it's quite easy for you to find a few, and the values that they are more helpful for this. So if this is X and this is the sine of X, so if we use 90, 180, 270, and 360, put this in your calculator, you get that the sine of 0 is 0, the sine of 90 is 1, the sine of 0, the sine of 270 is -1, and the sine of 360 is 0. So remember that this thing is quite handy because you know that it's going to start like that and then it's going to go like this, and you can then remember that it's going to be 1 and then it's going to have to go down. So 180 is 0, and you can always check this very quickly with your calculator. 270 -1, 360. So this is just in case some of you may not remember this, but it's very, you put the values in the calculator, and then this is the graph of the sine. So we'll be doing more complicated things with it. So this is just to make sure that everybody is comfortable with this. So as I said, if you remember that it looks like an S, it's quite helpful to remember that. Then we the cos, and the cos, I just remember that it's like a cup. Okay, so imagine that it's like a cup. So the cosine is like a cup. And if you go into your calculator, you've got X here and the cos of X. So you put them in later, and you got 0, 90, 180, 270, and 360. Really quickly in the calculator, you got the cos of 0 is 1, cos of 90 is 0, the cos of 180 is -1, the cos of 270 is 0, and the cos of 360 is equal to 1 again. So the values that we've got 0 and then 1. Then when it's 90 is 0, when it's 180 is -1, 70 is 0, and when it's 360 is 1. So it's this cup that I mentioned here. So you've got that there. Then 270. And remember that obviously the sine and the cosine keep going on here. They've told me to only put it between 0 and 360. Okay, so this has things as almost like bull, but I just this mnemotechnic rule that the cosine is like a cup. You may find that helpful to remember. Now the tangent is a little bit strange because, as you know, the tangent has some points in which explodes. The calculator gives you error. So if you think of 0 and 90, 180, 70, and 360, you can see that, well, if you find the tangent at you get 0, but then at 90, it gives you an error. And at 180, is 0 again, and then at 360. So what happens here, you probably know, is that you've got asymptotes there, and you've got an asymptote there. So just to remember about the graph. And it goes like that, the tangent. So it goes up to infinity. You can, for example, check what happens to the tan of, say, 89.999 You can check that in your calculator, and you can see what happens to the tan of 90 in, say, 0. So what happens very close to the left, 89 point something, and what happens to the right of 90. And you will see that the graph that you got a negative value. So then it goes like that, and then it goes like this. And again, if you go to 270, you can see that it will explode, and then it will go like this. So this is just a reminder of the graphs. So now let's go to the meat of it. Is a typical question that you've probably seen things similar to this in your in past paper. So you got the graph of sine of x, they're given is to us, and we are given one solution, okay, which is 210, and they want me to find another solution. Now, the best way of understanding this question is that when I am solving sine of x equal to minus 0.5, same as if I was finding the intersection of y equals sine x and y equals to minus 0. So if you remember doing simultaneous equations, what you do is you put the y equals to each other. So of course, is the graph of the sine of x, but what is the graph of y equal to minus 0.5? That this means that y is always 0.5, so it's a horizontal line because it never changes, it's always minus 0.5. So what I need to do with that is that I come here and I say, well, what is y minus 0.5 is over here, minus 0.5, and then I just draw a horizontal line like so, and then I'm gonna this y equal to minus 0.5. So of course, as you can see, there are two intersections. We've got that one and we've got that one. So the first solution, it says that is 210, and as you can see what it corresponds. So we've got there, and then you've got 210. But remember that there is a symmetry in the graph of the sine. There is this symmetry. I'm going to put it in a different color. So that length in there is going to be the same as that length over there. Corresponds to this point here. So of course, 2010, so 200 is 180 plus 30. So that means that this length is 30. Of course, if this length is 30, that length is 30. So obviously I'm going back. So that means that that value is going to be 360 minus 30, which is 330. Okay, so the other solution is going to be x equal to 230. And always, this is a top tip, just check. You put in your calculator the sine of 30, and if you put it into your calculator, it will give you minus 0.5, and then we go, yes, we got it. So you click in your exam if you got it right or wrong. Okay, so this is one for the sine. We're going to do now with a graph for the cos, and in this case is saying use your graph to solve cos of x equal 0.5. So again, remember that solving cos of x equals 0.5 is the same finding the intersection between y equals cos x and y equals 0.5. Got my cup, my cos cup is there. Y equals 0.5 is going to be a horizontal line. It's always 0.5 when there. So I just draw this horizontal line there. Okay, and I'm just gonna just because I can. So I'm just gonna label y equal 0.5. So it says use your graph. So I look at the intersections. So I've got there and I've got that one there. So obviously I want to find the x's. So if I go down there, it gives me that value there. And if I look at the other one, it's going to give me that value there. So that means that x is equal to 60 and x equals to 3. And again, top tip, you go to your calculator if it's in your calculator paper, and then you find the cos of 60, the cos of 300 in your calculator, and then you know if you got it right or wrong. Okay, so this is another type of questions that they may ask with trigonometric equations. Okay, so we're now going to move to another one of these, and again, sketching the graph of cos. Remember that cos is a cup. I know that there is a line of symmetry right down the middle for the cosine. So remember that the cos start at 1, then it's got 90. So these are things that we have to basically learn, or if in doubt, go to the calculator. So that is my cos cup. They're telling me one solution of this cos equal to 0.766 is x equal to 40. Okay, so remember, that's the same idea as before. Solving cos equal to 0.766 is the same as finding the intersection of y equals cos x and y equals 0.766. So remember, y is a constant, y never changes, so it's a line. This is 0.5, that is 3/4, so this is just slightly a little bit higher than that. So let me indicate it. So that is 0.766. Horizontal line. So I'm just gonna get my line there. Horizontal line that I put across. And then I just label it. So y was 0.766. Okay, so they're telling me one of, so I know that when they intersect, that value is 40. So remember that there is a line of symmetry. So I've got this other point here. So if you look at this, we have 40 degrees there. So that means that that length there, because of the symmetry, is going to be 40. So what it means is that this length is also 40 degrees. So because I've got 40 degrees going backwards, this is going to be 320. Or if you prefer, I can just write here 360 minus 40 is 320. Okay, so the other solution will be x equal to 320. You can see that it's always the same idea. I've got a horizontal line, I've got the graph of the cos or the sine, and then I find that. Okay. So we're moving into this next topic that I know that some students find it tricky, and is shading regions. So if you can, please, you can write these three inequalities. So the important thing is because it's greater than or equal. So remember, equal or less than or equal, we use a continuous line. What if this is greater or less? Use a dotted line. So that is important to find out. So to define the region, first we find the boundaries. So obviously the boundaries of the regions are going to be x equal 3, y equal 1, and x plus y equal 5. Okay, we then sketch them. Sketch the boundaries. So obviously we can do that very easily now because we've seen that equals 1 is always 1, so it's a horizontal line there. So this is y equal. It's convenient to keep track of them because we can do with lots of lines. And then x equal 3, this one is a vertical line because x is always 3. So that point is 3, x is 3, x is 3. Doesn't matter how y changes, always going to be 3. So we draw this vertical line like this. Now, so we sketch the boundary, and what you can see is that x has greater than 3. So x can be 4, 5. So we are all right. So we can just shade everything that is there. We could shade that as well, but because I've been told that y is greater than or equal than 1, it means that I don't need to shade that because it's greater than or equal than 1. So the next step now is to take a look at this here. So if we do x plus y equal 5, we can rearrange as y 5 minus x, and we can give any value that we want, but we usually go for the intercepts. So you can see that if x is equal to 5, y is equal to 5, 5 is equal to 0. So this is 0.50. So this is 1 point of that line. And for example, if we put when x is equal to 0, y is equal to 5 minus 0, which is 5. So it gives me the point 0, 5. So 5, 0, 0, 5. And I'm going to have to cheat using the lines because it will probably be all over the place if I try to do it by hand. So I'm going to have to cheat. So I'm going to connect that, and let's not forget to keep labeling them. So this one here is, so this is x plus y equals 5, and this one here is, it was x. Now the important thing now is obviously which bit do I shade? Is it the right hand or the left hand side? So it's always good. So so to shade x plus y less than equal than 5, it's always good to check, for example, what happens to the point 0, 0. Okay, is 0, 0 in or is it out? Okay, if we check, 0 at 0 is less than equal than 5. So the point 0, 0 is part of the region, so I'm going to have to shade the left bit. But remember, we already knew that x is greater than y is greater than 1. So what is left to shade is the left of. So this is below x plus y equals 5, but remember, is to the right of x equals 3 and is above y equals 1. So this is a top tip to actually, if you got one of these ones that is quite tricky to see, check what happens to the 0. So is 0, I need to shade this part. If 0 wasn't there, I will have to shade the other part. So let's take a look at the next one of these. So just to practice this one. So if you can please write down these inequalities, and you can just draw a pair of axes. We've got y less than x, y greater than equal than 1. So here, alert, we're going to have to use dotted line. This is going to be continuous and continuous. So it's always important to realize if we need. So again, if we look at the boundaries are y equal x, y equals 1, x plus y equal 4. So as per usual, we're going to sketch these lines, and then we will look at the region. So y equals x. Remember that this is the bisector, so that means that the x coordinate is equal to the y. So if x is 0, y is 0. If x is 1, oh sorry, this is a slightly scale, so that's important because that's the 1. Sorry. So if x is 1, y is 1. So be careful with the scale. So that's 1, 1. If x is 2, y is 2. If x is 3, y is 3. If x is 4, y is 4. It looks a little bit different because the scaling is different. So I'll just put a line across them. And that is the line y equal x. But you probably have a better, if you have done equal aspect in both, it will look like an ordinary y equals x. As you can see here, x is greater than y. Okay, so if we're trying to shade this one here, y is less than x. For example, if we pick this point here, the point 5, 2, you can see that y2 is less than the x. So that means that the region is here, is down here. So it's always good to check where one point is. So 5 you can see that the x is greater than the y. The next one is y equals 1. We are used to this one because this is just a horizontal line. So we've seen this before with the trig. So y equals 1, we've got in here. But remember that we want to shade y greater than or equal than 1. Okay. And actually, sorry, I'm gonna do this one because I've made a mistake that this should have been I should have to do dotted because that this one should be a dotted line because it's less than, not equal. So let me just change that. Sorry about that. So it's really that we are very clear about this. So if we've got that line should be dotted. Okay, so because it and not equal. So because we are shading now, we are shading now above the 1. So we're going y greater than 1. So we want the values of y that are bigger than 1. And I can just shade this in a different direction if you want, like that. So that means that it's going to be okay because we want it above there. And then as before, we want x plus y less than equal than 4. So y is 4 minus x. So we go for the intercepts. So when x is 0, y is 4. For example, when x is 4, y is 0. So we've got the point, different color. We got the point here, 4, 0, and the point 0, 4. So we just remember is less than or equal, so it's got to be a continuous line. So with that one there, and it's telling me that x plus y is less than equal than 4. So again, as we did before, let's check 0, 0. So 0, 0. So remember 0 at 0 is less than equal than 4. So I need to shade this side on this side. So finally, the region that I need to shade is going to be this region here. Okay. So make sure that when you do that in the exam, it's very clear that this is the region that, and of course, make sure that that is. Okay, so this is about with the in this this one here. So I'm mindful of the time. I want to do more things. So this one, the only thing that you have to be careful is that you can see that x is in between -1 and 2. So the -1 and is never 2, but in between. So we're shading something that is in between. I'll do this one quickly so you get the idea. I need to shade that is in. Then we've got y less than or equal than 8. So remember that this is equal, so we can do it like that. So of course we want to shade this bit here. So we know that we have to be below 8. And then we've got here, which is y is greater than 4x minus 4. So if we try to plot this one here, so for example, when x is equal to 0, y is -4, and if you want to choose another value, for example, I don't know, when x is equal to 2, y is 4 times 2 minus 4, minus 4. So this is the point 0 minus 4, the point 2, 4. So we got 0 minus 4, the point 2, 4. So I join them together. And as before, you can see y is got to be than 4x minus 4. So do I shade underneath or do I shade at the top? Well, because the y is greater than, that is going to be that bit there. But as usual, just to make sure, we get the 0, 0. What happens to 0, 0? Is it in or is it out? So you got 0. It's 0 greater than 0 minus 4. And the answer is 0 is bigger than -4. So that means that this one is in. So 0, 0 is in. So remember we had that from before, less than 8 in between them. So what I have to shade is going to be all of that there and there are going to be. So it's to the left of the line, and then I just shade all that, making sure that the boundary is dotted. Okay, so make sure that the boundary is dotted. So as you can see, you can practice more of them, and it's always the same technique. Now we're going to now look at these iterative methods, location of roots. So obviously this is just to determine where the roots are. So you have this equation, the values of x for that. So you are given a few values of x and a few values of y. So it says between which consecutive integers is there a solution to the equation. So if you think of this graph, so you got at 0, you've got -10, at 1, you've got -18, at 2, you've got -18, at 3, you've got -7, and then at 4, you've got 22. So of course you can see that if this is a polynomial, which means that it's continuous, so what is going to happen is that at some point between 3 and 4 is going to cross. So the graph is going to cross. So because you've got a positive y and a negative y. So the best way to explain this is when x equals 3, y is equal to -7. When x equals 4, y is equal to 2. There is a change of sign. So between 3 and 4, there is a solution. So this is the way we locate where the root is. So if you've got value where y is negative and a value with y is positive, then there is a value in between. There is a value in between alpha. So there is a value in between where there is a root for the equation or a solution. So we locate them. Now, hope that you've got your calculator handy. So make a note of this. Make a note of this iterative formula. So basically what we do is when n is equal to 0, okay, when n is equal to 0, you've got x1, because remember n is equal to 0, x1 is 8 minus 5 divided by x0 square. But x0 is equal to 1. So we've got 8 minus 5 divided by 1 square. So we've got 8 minus 5 divided by 1 square. So what I'm going to show you is how we can use the calculator to find the different values. Because x2 will be 8 minus 5 divided by x1 squared. But with the calculator, using the ANS button, we feed that value back into it. So let me show you, let me share with you a calculator, which, so how we write this calculator. Let me just share with the calculator. Yeah. So if you look at your calculator, sorry, let me just. I mean, your all your calculator needs to have is all the calculator needs to have is an ANS button. So remember that we've got 8 minus 5 divided by 1 square. I mean, I know that you all know how to find this from the top of your head. But when we do that, so you put that in your calculator and you get that answer. Then what you do is you go back and instead of 1, you write the ANS. So what that means is that you are feeding the 3 back again, and that gives you 67/9, or if you want to put it as a decimal, for periodic. Okay, so x1 is 7.4 periodic. Okay, and for the next one, okay, so we feed in that, we press equal again. I mean 7.90. Okay, so we can keep track of that one on the board. So 7.9, and we can just write it to 10. So that is the value. So we have to keep track of what we're doing. Then the next one, we're gonna press it again. That gives me 7.920. And if we press it again, it gives me 7.203. So this is just to remind you how you can use the calculator. So I have kept on the, I have kept track on the, okay, I have kept track of what we remember. We started the very first one, 7.4. I put it on the ANS, it gave me that. I put x3, 7.920. 4, you got 7.9203. So it's just how to use the calculator effectively. So just before we finish, just a very quick reminder of the circle theorem. You have to learn them. That the tangent, the angle between a radius and a tangent is 90. The tangent from a point have equal length. The alternate segment theorem. That means that that angle will be the same. These two, they are the same really, because if you've got that angle is half of that. So obviously that 180 and that is 90. This one is quite easy to remember because the angles look very, very similar. They look the same. They're the same. This other one where you've got a quadrilateral inside. So make sure that you got them in a flashcard or you remember them, and it's only a matter of you identifying which one I need to use. Usually, well, for example, in this first one, it's pretty clear to know it's going to be a 90 degree, because obviously this one is 180. So obviously that angle be, remember that 180 will be equal to 29 at 90 at the angle B. Okay, so obviously to go 180 is going to be 119 plus B, and then you just find that B is 80 minus 190. Another one just to, so for example here, you've got that one, and that is going to be half of that. A quick way of doing this, so you can just chunk it and you have 100 at 12. So if you divide each of them by 2, you go and 6. So your answer is 56. Just quickly mental arithmetic for that one. And for example, to find the size of the angle DAB. So remember that we always, so to find that one, you can see that A plus 62 is 180 because they're opposite in equal. So this one is going to be 118. Okay. And then to find B, you know that B is going to be, they all add to 3. So B is going to be 360 minus 118 minus 95 minus 62. So I will probably do an specific session of theorems if there is demand for that. Just before we finish for today, if anyone would like to in the chat, please, what topics, and then we can have a more concentrated session in some of those topics. So I've already have some suggestions about exponents and indices. So before you go, if you could just type on the, please, on this chat, if you could please write sine and cos rules. Excellent. So yeah, sine and the cos, I'll make a note of that. So thank you for that, Shia. So sine cos rules. If anyone else has got any, please, just before you go, let me know what you would like me to. Graph transformations, that's really good. Yeah, absolutely. Yeah. Graph transform. Excellent. Please just keep them coming. So as I said, we finished for today. Hope you have found it enjoyable. I'm going to stop the record now.